Hello class, this is CSE-4410, Sections 1 and 2, Chapter 7, Spring 2025. Alright, Chapter 7. We are skipping a couple of chapters in the book, because they are more related towards making 2D games. Chapter 1 was an intro that we basically skipped over. Getting familiar with Unity, I just shoved that into Chapter 2. Chapter 2 was getting familiar with 3D coordinate space and making a simple scene in Unity. Chapter 3 was adding scripts to the scene, the ability to shoot raycast, enemy movement, enemy AI, responding to the player's presence, and the ability to fire back at the player. That was Chapter 3. Chapter 4 was more to do with adding graphics assets to the game. Textures, skyboxes, 3D models, and a particle system. So, you'll probably notice that you have a next assignment as well. So that is assignment 2.5. I did not give it a due date yet, but it is a fairly short assignment where you just simply try adding a few assets to your scene. So you can either make your own assets, or you can find something that's royalty-free or public domain that you can freely use in your project. I'm still going to put out a bonus video on how we could make a simple turret in Blender, so keep an eye out for that. So Chapter 5 is writing a 2D memory game. It's a card matching game in Unity. So that is building a 2D memory game. Chapter 6 is building a two-dimensional platformer. I do have videos in the past that outline how to do this, so if you want to make a 2D game, you can follow along with that. For now, we're just gonna go forward with Chapter 7. So Chapter 7 is adding a UI to the game. What we're going to do is we're going to work with the project that we've been adding onto, and we're going to add a UI to it. So we're going to begin with what is a UI and what is a GUI. So a UI, that is a user interface. When we say UI, we might be talking about a graphical user interface, and that is a more specific thing. A GUI or GUI, a graphical interface, that graphical user interface, that refers to the graphical elements of a user interface. I'll be using the terms interchangeably even though they refer to two different things. A heads-up display, that is another kind of interface. That is where we superimpose graphics on the game view. So a heads-up display, if a graphical user interface is set up such that we have graphics superimposed on the game view, that's called a HUD. So, the first thing we should talk about is there are actually two modes to making a user interface in Unity. The first one is called immediate mode GUI. This is where we use draw commands that in a onGUI method, and that onGUI method is called every frame. I already have the project that we've been working on already opened here, and meanwhile, I have already reopened the code here. So if you recall from the past few chapters, give me a minute. Okay. Nothing too important there. Anyway, if you recall from Chapter 3, where we drew a crosshair on the screen, we used the onGUI method to draw the crosshair on the screen. But more specifically, we called GUI.label to place a rectangle at a specific set of coordinates in the screen, and then within that rectangle, we would place text that is simply a plus sign, indicating that is a crosshair. So, with that, there is another method that I would like for you to try, and that is GUI.button. So, GUI.button draws a button on the screen that we can click on. So, let's try it out. So, GUI.button, we pass in a rect. So, a rect, that is a rectangle. So, the 4 arguments for a rectangle, the first 2 arguments are the XY coordinates of the rectangle's upper left-hand corner. The next 2 arguments after that are the size of the rectangle, so the width and the height, extending from that upper left-hand corner. Now here's the weird thing. The XY coordinates on your screen are upside down. So the X coordinates, if you see my cursor, if you can see my cursor, it's at the upper left-hand corner. So this is the X-axis, and I'm moving it, and from left to right, that's the positive X direction. Up to down is the positive Y direction. So the Y-axis is pointing downwards, so it's upside down. So when I say new rect 10, 10, it's placing a rectangle starting from 10 left and then 10 down from the screen. And then when I say 180, 20, that rectangle is 180 pixels to the right and then 20 pixels down. So GUI.button, we're going to pass in a new rect 10, 10, 180, and then 20. And then I'm going to pass in some text. Let's say, does anyone remember those days where we have like advertisements online that's something like click here for a free iPod? Okay, so here's the thing about GUI.button. It is a method that returns whether it was clicked on during that frame. So if it was clicked on, we can do stuff. So I'm going to say if GUI.button, we're going to draw this button, and it's going to return true if it was clicked. If GUI.button and this whole method evaluates to true, we're going to simply say button has been clicked. Okay, so if we click the button, it will do stuff, and in this case, it's going to say debug.log button has been clicked. So let's try this out really quick. Run, and see how the text is in the button is in the upper left-hand corner, because as I said, the Y-axis on the screen goes down, not up. So I can click this. My bad. I can click this. But the problem is, if I try to click it with the settings that we have for the screen, it's not going to work. So I need to turn off a few settings first. So, let's just comment out these 2 lines of code so we don't lock the cursor and we can still see the cursor. So, with that change, I can now click on the button as many times as I want. And in the console here, we can see that's been clicked. We are clicking the button successfully. Okay, nice. So we can draw a button on the screen just like that. So, I guess now the question is, do we build our UI using immediate mode or the other method that is retained mode? Well, they both have their pros and cons. I guess immediate mode has the specific advantage of we can create UI elements rather quickly. However, the rest of the chapter here is about retained mode, where we develop the UI in the editor itself. And that has the advantage of we can see what the UI looks like before the game even runs. So here's a sketch of what we're going to be making. We're going to be placing a few UI elements in the corners, and we're going to add a pop-up window in the middle of the screen. the pop-up window will only open if we have the player open it. So one of the buttons, that is a settings button. It will open the pop-up window when it's clicked. And then from there we can change settings about the game. We also need some UI elements. Now, the author has a GitHub repo that contains all of the completed projects. What we want to do is click on this link, go to the assets folder in this chapter 7 project here. We just need the 4 .png images here. So close.png, enemy.png, gear.png, and popup.png. Download all of those right now, and I've already downloaded these images quite a while ago, so what I'm going to do is these images are already in my downloads folder, so all I got to do to import them into my project is a simple drag and drop operation. So what I'll do is open this project view here, go to the assets, and simply drag and drop all 4 required images into our game. So now we have them. Let's create a brand new folder and call it sprites. So oops, that is not meant to be a script. We need a folder. So let's fix that up. Create folder sprites. And I'll simply drag and drop all 4 sprites into here. Okay. When we import these, we can select them all in the inspector and change a few things about it. We need to change the texture type, the sprite. This step is necessary because in a 3D game, images like these can be used as either a sprite or a material. And if you recall from last chapter, we worked with a material. We used a image that would be used as part of a material, and then we used the material to be applied onto a 3D model. So this is necessary for a 3D game, but in a 2D game, virtually all images are just going to be treated as sprites. So let's go in Unity and fix that up. So with these 4 images selected, change texture type, the sprite, 2D and UI. There we go. So now we have sprites that we can use for our user interface. Unapplied import settings for 4 files, save. And if you look closely, there was also an apply button here. Clicking that would also work. Okay. So let's begin with the next task of creating a UI. Go to Game Object, UI, Canvas. And it will create 2 things. The first one is the canvas, which if you look really closely here, you'll notice that it is enormous. Another thing that's created is a game object called Event System. So we're not really going to get into the details of that just yet, but this is necessary. This is made alongside the canvas. So let's go back to the canvas for now. It is huge. And that's because 1 unit in-game is 1 pixel on the canvas. And the other thing is, the size of the canvas dynamically changes with how large the scene view is in here. So I can stretch and squish the window here, the scene view, and it will stretch and squish the canvas accordingly. So if I make this wider and narrower, you'll notice that the canvas is changing size accordingly. Another thing I can do is I can fix the size of the screen. So you probably won't have these. These are presets that I made during my own time. These are some of these are screen size resolution presets that I made. You'll probably have presets that look like this. So WXGA, that is 1366 by 768. If I click that, it will constrain the size of the screen to be, well, that many pixels. 1366 by 768 pixels, and that constrains the size of the canvas so that it's 1366 by 768 units large. And remember how I said that in Unity the Y direction is height and the X direction is width? Well, you probably start to see as to why Unity works that way. Because if we treat the screen as the XY plane, then to extend it into 3 dimensions, you gotta imagine the Z-axis as going from your eyes into the screen and into the scene, in a way. And that's exactly what happens because, well, if you look really closely, you'll see the blue arrow that represents the Z-axis. Basically, this canvas is a stand-in for the monitor itself. So, in front of the screen, that is you. And into the screen, that's the forward direction. We're looking forward into the screen. So that's why Unity works with the That's why Unity works with the Y-axis as height and the XZ plane as the floor. Because that's, if you think of the monitor as being the XY plane, then it's only natural to think of the Z-axis as going into the monitor and giving us a sense of depth. Or at least that's how I like to think about it. As I said, if you imagine the XY plane as being the monitor, then the Z-axis goes into the monitor. So that's why Unity works with these left-handed coordinates. Okay. The next thing to talk about are render modes. So, we can change this, but for our purposes, we can leave it as at the default. So if we click on the canvas and then look at it in the inspector, render mode, there are 3 modes. The default is screen space overlay. That renders the UI as 2D graphics on top of the screen. Well, on top of the camera view. Screen space camera, same as before, but we can rotate UI elements for perspective effects. And world space, this places canvas objects within the scene as if the UI were part of the scene. So, for our purposes, we're just going to leave it at the default of screen space overlay. Another setting that we want to check off is pixel perfect. This way, if we select pixel perfect, then if we have pixelated elements on the screen, there will be no fuzzy borders on the borders between 2 different colors. So we want to have that selected. Okay, so now, let's add some elements to the canvas. So, we're going to add one each of the following: a button, a text element, and an image. Let's begin the element first. So UI. Okay, so game object, UI, and image. It's up here. There we go. So it's currently blank right now, but we can work with that. We can deal with that a little bit. Oh, by the way, if you're kind of annoyed trying to get this thing perfectly lined up with the screen, click that. Click the axes up in the upper right-hand corner, and it will perfectly line up the camera so it's looking perfectly directly at the screen, well, at the canvas. And then if you double-click this, it will zoom into the canvas so we can more clearly edit it. So now we can move these elements around the screen as though we were editing. So this gives us clear view of how we edit the UI. It's just click on the axes over here from perspective to ISO. So this is an isometric view of the scene, but with the z-axis. Like, the z-axis is still there, but it's perfectly lined up. So if you were to draw the z-axis, it would technically have to come out of the monitor from behind. So this is how we get a good view of the. That's how we get a good view of the canvas, so it's easier to edit with. So we edit our image. We're going to add next text. So this is a text element that requires something called Text Mesh Pro. If you've never created a text element like this before in your Unity project, you will be asked to import TMP Essentials. Do so. Click that. Give it a minute. And you don't need to import the example, so we're done here. So Text Mesh Pro was its own third-party plugin for Unity that became a part of Unity itself. This has long since replaced the older text system, so now, yeah, there is an older text system that Unity itself has relegated to legacy purposes. So we could use this, but I think it's it's just more versatile to work with Text Mesh Pro instead. Okay, so now we have an image, we have a text element, and now we need a button. Button Text Mesh Pro. There we go. There we go. What we want to do now is we want to align these items as follows. Let's take this image and put it in this corner here. Let's take this text element and put it right next to the image element. Finally, let's take this button and put it on the right corner here. Okay. Let's now select the image element and change the sprite. So the sprite for that should just be the enemy sprite. Since we have the sprites folder already open down here, let's simply drag and drop the sprite into there, and there we go. That image element now has our sprite, but it's not the right dimensions, because if you look in the sprite view, you'll know that it's supposed to be a bit taller than that. Right now it's a bit squished. So to fix the fact that the enemy sprite being squished, all we gotta do is click on this button here, set native size. There we go. So now it's no longer squished, and now it's the correct proportions. Let's move these elements a little bit like that. So let's look at the button next. So it also has a sprite element. We want that to be the close sprite. Okay, it is not the right size, so click set native size. That will change the proportions of the button so it is of that of the original sprite. Right, so, oh, my bad. That was supposed to be the gear. So let's fix that. Click set native size. There we go. So we're going to be using the close button for something else. My bad. Okay, so now we have our UI nice and set up right now, but I'm going to do something here. Let's squish that UI. Squish it. Well, nothing's happening right now because I have the screen resolution fixed to this 1366 by 768 resolution, but if I choose free aspect, you'll start to see a problem. If I squish the UI, notice how the UI elements are eventually moving off the screen because the screen is so narrowly squished. And that's because the anchors for these UI elements are not properly set up. So let's do this. I'm going to take the image and text elements and move them back up here. And you notice how we have this X in the middle of the screen? So it turns out those are settings for our anchor. That is where our anchor is. So if I select the image, and in the inspector, I click on this thing that looks like a crosshair. If I click this, that will anchor the image to the upper left-hand corner. So if I change the screen size by resizing the window like this, now the enemy sprite moves with the corner instead of moving relative to the center. We need to do this with the text here. So select the text item, click on these crosshairs, and select this anchor position to be the upper left hand corner. So now if I resize the screen, again, the text moves with the corner, not the center of the screen. For the button here, same deal. Select the button, put it in the right position, and we want the upper right hand corner. So there we go. Look at that. So now, matter how I resize the screen, the 3 UI elements will still be where they are. Oh yeah, let's do one other thing with the button here, and let's erase all that text. There we go. Okay. Actually, what will also work is we delete the text. So we're not gonna have text on this button, so we can either just erase the text, or better yet, we can just delete that text item from the button. So the button has its own text item. We're not gonna use it. Okay. So now we have our UI all set up. Now, let's begin with our next step. So far, all we've talked about was changing the anchors for our UI elements. Now we're looking at section 7.3, programming interactivity in the UI. Previously, all the way back in chapter 3, we added a few lines of code that would lock and hide the cursor from view. We actually need to comment out those lines of code so we can properly click on the button in the UI. We kind of already did that when we were playing around with the immediate mode button method. So if you haven't commented out these 2 lines yet, comment them out now. Meanwhile, in the same script, we need to make a change. If input.getMouseButton down, we're going to perform a raycast. However, we don't want to perform a raycast if the cursor was hovering over one of the UI elements on screen. So we're going to add an extra condition. So the 2 conditions are as follows. Input.getMouseButton down, 0. So if the left mouse button is depressed down, and not event system dot current dot is pointer over game object. So right now it isn't working. Yeah, it doesn't know what the event system is actually. So we need to add another line of code up here, and that is using Unity engine.eventsystems. So yeah, we need to add an extra line of code to our boilerplate up here. So this should work now, but oh, now you know. Now you can see what I did wrong here. That was supposed to be a method call is pointer over game object. So as I said, using Unity.eventsystems and add an extra condition, not eventsystem.current.is pointer over game object. So that way, we only perform our raycast if our cursor is not over any one of our UI elements, okay? Okay, so now we can click on UI elements and it doesn't perform a raycast now, okay? We can try that out real quick, so. I can click, click, click on the screen, but I can click, click, click on the button over here. If I do the same thing here, I can click, 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 click on the screen, and it's not affecting, it's not clicking the, it's not, basically it won't perform a raycast if I'm clicking one of the buttons here. And neither would it perform and neither would it work with I did this either, so. Actually it does work, but, actually it does work because this is an earbud, so that's different. So if I click, 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 notice how I am clicking on the screen and there are no shots being fired at the wall. That's because, well, it won't fire shots on the wall if I am clicking on the button here. Okay, so that's one issue done and dusted. Okay. You'll also notice that the button, no matter how many times I clicked it, nothing happened yet. And that's because we haven't programmed the button to do anything yet. Okay. So here's where it gets interesting. So this is 7.3.1. We're gonna add in a UI controller. In general, UI interaction is programmed with a standard series of steps. Create a UI object in the scene. We just did that right now. Write a script to call when the UI is operated. Add the script to an object in the scene, and link UI elements to the object with that script. So, our next step is to write a script to call when the UI is operated. So now we're going to create yet another script. This script is going to be called UI controller. C# script, UI controller. What we're going to do next is we're going to add a empty game object. So create empty. We're going to zero its transform by resetting the transform. So this places the scene controller, no, the UI controller. Oh, we could, so here's the thing. We could make a separate UI controller game object. But since we already have a scene controller game object upon which we attached our scene controller, it would also work if we took our UI controller script and attached it to our scene controller as follows. So this also works. In fact, it's probably more organized to have a single scene controller that has both our UI controller and our scene controller scripts. So now we have both a scene controller and a UI controller. Next, we're going to add the following code. So we need to open up our UI controller script, and we're going to add the following code. First is a field. Serialized field, EMP text, score, label. So notice that isn't working because we're not using the right namespace. So we're gonna have to add using tmpro. So now the compiler knows what tmp text is. Next thing we're gonna do is we're gonna add a line of code to the update method. So score label.text equals time.realtime since startup.toString. So realtime since startup is, well, exactly what it sounds like. It's the number of seconds that have elapsed since the game has started. The string, because we want it to be a string. We're gonna then add another method here. Oh, my bad. This should not be in the start method. That should be in the update method. So let me just copy paste that. And we won't be needing a start method here, but I'll just do that. We need one method here, and that is public void on open settings debug.log opening settings. Okay, So this is actually going to be a method that's going to be called when we click on the settings button here. Okay, so with that, let's select the scene controller game object so we can view that UI controller script in the inspector. So there's currently nothing assigned to it just yet, but remember we had made this text item here. We're going to drag and drop this text item into this slot here. So now if I play the game, what should happen is it's counting out the seconds since the game has started. Okay? And we did that for testing purposes to show that the text can update. Okay. We also had written a method in our UI controller script, and that method was onOpenSettings. Here's what we're going to do next. Let's select the button here. And, okay, so the gear is kind of in the way, so I'm just going to minimize this view down here. You'll notice the button component has a little thing called onClick. Let's click this little plus button down here. What we're going to do, see that little slot there for a game object? We're going to drag and drop the scene controller into this slot here. And then, in this field here, that says no function, we're going to select UI controller. Now, it's a little bit hard to see because my face cam's in the way, but let's do that again. So I'm going to press escape to erase that, and let's do it again. Drag and drop the scene controller into this slot. Then, select this drop-down menu that currently says no function. Select UI controller, and then what we want to do is select the onOpenSettings method. What this does is whenever we click the button, this button in the scene, it's going to call the onOpenSettings method that we had written in here. So that means if I run the game now and I click the button, it's going to call the method onOpenSettings, which currently has the bug.log opening settings, and it just opened our settings. So now we have the button doing something. Okay. What we want to do next is create another UI image. So, game object, UI, image. So now we have another image in our scene. We're going to be using this for our pop-up window, so I'm going to rename this to pop-up. There we go. In our sprites folder, let's open that up. We have this pop-up. We have this little pop-up sprite here. What we're going to do is drag and drop that pop-up sprite into the source image field here for our pop-up sprite. So now we have this image, and now this image, we're going to be using it for our pop-up screens. So one thing we can do with this pop-up here is we can adjust the size, we can adjust the width and height of our pop-up window to be as large as we need it to be. So there you go. But it doesn't look good. And you'd be right, it doesn't look good. That's because we need to slice our image so that you'll see what I mean. So we need to slice our image into what is called a 9-sliced image. So if you can imagine the corners being constrained so that they don't stretch at all, we are basically stretching the edges and the center so that they are stretched instead. That way, when we resize this image to any size we want, the corners stay the current size that they are, and everything else is stretched. So the edges only will stretch one way, and the center will stretch along the X and Y axes. What this allows us to do is make windows such as this. We can make windows like this, but they can be stretched arbitrarily to whatever we want, and the borders and the corners will stay their original proportions. So this is something we have to edit. So in the inspector, we need to open up this pop-up texture in the inspector. Click on Sprite Editor. Now what will happen is, no Sprite Editor window registered. Please download 2D Sprite package from Package Manager. So, since we are working with a 3D project, we don't have the Sprite Editor available to us. So we need to actually install that. So, we need to open up the Package Manager. So to do that, go to Window, Project Manager. Oh, my bad. It's Package Manager. I need to fix that in the slides. So we've opened up our Package Manager. We're then gonna type in here 2D Sprite package. So it's not showing up in here, but we want to select in this drop-down menu, Packages in Project? No, Unity Registry. So we need the Sprite package. Okay, there it is. We want this one here. So 2D Sprite, install. Alright, so now we have the 2D Sprite package installed. Let's open up our sprite in the inspector again. Let me move this to the side. Okay, so select the pop-up sprite in the sprites folder. In the inspector, click Sprite Editor. So now we have this view here. We want this to be 9 sliced. So, you see these little green nubs here? I can drag this down and drag this handle up. Drag this handle to the right. Drag this handle to the left. And that is our 9 sliced image. Alternatively, you see these L, R, T, and B values? We can set those values individually to, well, the book should have us set it to 12, not 13. So let me just fix that up. So we can either drag these green handles, or we can directly type in values for L, R, T, and B. Once we have that done, click Apply up here, and now we have a 9 sliced image. We're not done yet. Select the pop-up. Select the pop-up game object in the hierarchy. Look for the image component and image type. Under image type, select sliced. Right now it doesn't look like much has happened, but if you look closely, and that's because it doesn't look like much has happened because my screen resolution is so high, but if you look closely, see how the borders are now, they're now properly scaled? That's because we are using that, since we're using a 9 sliced image, it's going to scale the borders and the center accordingly while keeping the thickness of the borders and the corners preserved. So now we can resize this image all we want, and the borders will remain the original thickness no matter what. We got it! What we want to do is change this pop-up so it has the specific dimensions of 250 wide and 200 tall. And the reason why it's so small is because I'm working on a 4K monitor right now. So maybe it would be a better idea if I changed the resolution to say 1080p. So now it's still way too small. So maybe a much better size would be something like 1366 by 768. That's even smaller. But now we can see what our canvas will look like on a 1366 by 768 resolution screen. Nice. Okay, so once again, 250 wide and 200 height. Also, another thing is this. The layering order in the canvas determines how we layer UI elements on top of one another. So the thing is this. The further towards the bottom UI elements are, the closer to the front they will appear. So this is a layering order. So this new text item, I'm just gonna select that and move it here. Notice how the text is obscured by the pop-up. That's because, as I said, the further towards the bottom these elements are, determines the order in which these elements are drawn on top of one another. So with the pop-up element towards the top, it is now rendering behind the text. If I drag the pop-up towards the bottom, now the text is rendering behind the pop-up. Let's put this back. There we go. So, one more thing. Now we write a brand new script for our settings pop-up. We're writing quite a few scripts here. So, I'm going to go to my scripts folder, create a brand new script. This is called settings pop-up. Alright. Now we have a new script. Let's add the following code. So this is our settings pop-up. Let's inherit from mono behavior. For now, we're just going to add a start. No. We're going to eliminate all the methods that were included into here. We're simply going to add an open and close method. So public void open. And we're simply going to say GameObject.set active true. And finally, public open, public void close. We're going to say GameObject.set active false. So these two methods are both calling GameObjects.setActive. This turns on and off game objects. So if you say set active true, it turns on a game object. If you say set active false, it turns off a game object. Let's go back to our UI controller. So it's all the way over here. Let's add a few more. Let's add another field. That field is serialized field, settings pop-up, settings pop-up. There we go. Let's add back our start method. Private void start, and we're simply going to say settings pop-up.close. In the onOpen settings method, we're going to comment out our debug line and write the method settings pop-up.open. There we go. So now we are now able to open our settings pop-up. But now we've added a new field to our UI controller. That means the scene controller game object, which has both the scene controller and UI controller scripts, now has a field for our settings pop-up. We made this pop-up already. Let's drag and drop it. It's not working yet. So we need to drag and drop the pop-up into... Okay, so notice how it's not working yet, and that's because we actually need to attach the UI controller script onto our pop-up. So our pop-up does not have the UI... It does not have the scene... No, the settings pop-up script attached to it. So select our pop-up and drag and drop the settings pop-up onto the game object here. So drag and drop the settings pop-up script. There we go. So now we have the script attached to our game object. Now we're able to drag and drop the pop-up into this field here. There we go. So let's try it out. If I play the game now, and I click the settings button here, it opens our pop-up. But there's nothing in the pop-up yet. That's what we're going to do next. We're going to populate our settings pop-up so it has some settings that we can change. Okay? Okay. The first thing we want to add is, of course, a close button. So, maybe the 250 by 200 size setting is a little too small for our purposes, so let's fix that up so we can make this pop-up as large as we want, and it wouldn't matter either way because oh, actually, no. We shouldn't resize it like that. Rather, we should resize it using using the rect transform width and height settings here. So I'll just change that. There we go. So now we have a better size pop-up. So don't change the size of the pop-up by using the scale tool here. That will screw it up. Rather, we want the width and height to be adjusted using the width and height fields here. Actually, we should reset the scale so that way it's scaled properly. There we go. Once again, we probably want to change the size. There we go. Okay, next. Let's add another button to our UI. So, UI button. We want this to be the close button. This button should be a child of the pop-up. Oops. Drag and drop the close button so it's on over the pop-up. Now it's a child of the pop-up. We want the button to be in the upper right-hand corner. So I'm gonna drag it up here, and then we want to change the sprite so it's the red close button from before. So I'm gonna drag the sprite from the sprites folder into this image field on the button. Set native size, and for the text on the button, which once again is a child object of the button, we want to change it to close. But we want to change the font size so that it fits the screen. So maybe a size of 18, or maybe 16. There we go. Move the button so... No, move the button, not the text. So it's a little bit tricky because you have the button text here and the button itself here. So you just want, for ease of moving this around, just select the close button in the hierarchy. So now we can move the button itself. That moves along the text that was part of it as well. Let's also change the anchor for this button so that it's the upper right-hand corner. So if we ever need to resize this pop-up window here for any reason, it will still move it will move the close button with the corner. So the corner moves and the close button moves with it. Okay. Select the close button. And as before, we have this button component here with on click list is empty. click the plus, and here, drag the pop-up game object, drag and drop the pop-up game object into this slot here. Click here, select the drop-down menu here, settings pop-up. You want the method called close. So my face cam is obscuring it all. So click the drop-down menu, settings pop-up, close. So now if we click the close button, it will close the pop-up menu. So clicking the settings button here opens the pop-up menu. Clicking the close button closes the pop-up menu. Let's try it out. Click to open the settings menu. There we go. Click to close the settings menu. There we go. Open, close, open, close. All right. Let's add a few fields. Let's add a few more things to our pop-up window here. So we're gonna add two things here. One is a field for entering text. The other is for a slider. So let's go to Game Object, UI, Slider. And then Game Object, UI, Input Field. These two should also be children of the pop-up game object. So I'll drag and drop the slider and the input field. So now they are children of the pop-up. Next, let's position them so that they are roughly in the middle. So let's put the slider right below the input field here. Let's do this. There we go. And maybe our window was a little bit too tall, so I'll just squish that window. I am going to put these two UI elements roughly in the center. Okay, there we go. Okay, but we're not done yet. What we also want to do is add a field. No, not a field. We want to add another text object here. So UI, text message pro, make this a child of the pop-up. There we go. Position it so it is right above the slider. We're gonna want to change the size of it, so maybe a size 12. No, maybe size 18 was good. There we go. So now we have this text object so now we have this text object in here. Let us change the vertex color to be black. Okay, so now we have text in the pop-up. Let's change the text from new text to speed. So now we have a speed slider that we can manipulate in the settings window. Let's then select the input field here and change the text here so it's name. We can also change the size of the text here. If you wish to change the text size here, change the width only, not the height. A height less than 30 makes the text appear too small. Okay. Yeah, so we can change the point size here. Maybe the default was okay. So there we go. Okay. So now we have a slider and a name field. Let's select that slider because we want to change this. We want to be able to change what this speed slider is going to do is change the speed of the game objects in the scene. So with that, let's select our slider. Change the max value from 0. No, change the max value from 1 to 2. There we go. And now we have the ability to change the speed of our game objects so that they can move up to twice as fast. We could call this a difficulty setting if you want. Let's continue from here. So now that we have these changes made, let's return to the settings pop-up script for more coding. So let's open back up our settings pop-up script and add 2 new methods. On submit name, which accepts a name as an argument, or it's simply going to say debug.log name. There we go. And then on speed value floats, and then on speed value float speed. We're simply going to say debug.log, and we're going to format our string so it works as follows. So I'm going to preface our string with a $sign, and then I'm going to say quotation mark speed, colon, and then in curly brackets, I can simply write in the variable speed. There we go. So this is string formatting for C#. This way, when we have this speed field here. So we have this speed thing here that will be replaced with the value of speed. There we go. So now we are gonna work with the UI a little bit more. Okay, so we're gonna first select the input field here. Notice how there are these 4 areas here. Let's select on and edit and add to the list. Click that. And much like before, we're going to drag and drop our pop-up window from the inspector into this field here. So there we go. And once again, we're going to select settings pop-up, and we want... Here we need to be a little bit careful. So we want the method called onSubmitName, but we want the one under dynamic string, not static parameters. If you select the one under static parameters, there's going to be an extra field, and that is for passing in a predefined text value, which is what we don't want. We want to pass in whatever text was written in that input field. We don't want a predefined one. So I'm going to select the wrong one to show what it looks like. Settings pop up and select the one under static parameters. This is the wrong one. On submit name, there is an extra field that we can use to type in a predefined name. This is incorrect. We don't want the one under static parameters. We want the one under dynamic string. So if we select this one, on submit name under dynamic string, now whatever text was written in that field will be passed on to this onSubmitName method here. When we receive that text, we're gonna print out the name in the debug console. Now, next, we're gonna select our slider. So once again, there is a field, there's an area for our on value changed here. Click the plus, and we're gonna drag and drop. We're gonna drag and drop our pop-up window into here. Select settings pop-up and on speed value. Once again, I have selected the wrong one. We do not want the one under static parameters. We want the one under dynamic float. So that way, whatever value the speed slider was at, that value will be sent into the on-speed value method, and that is the value that we print out for the, that's the value we print out in the debug console. Okay? Okay. So, that is quite a bit of work that we had to go through just to set up the UI. There is a way we can do this in code, but let's just follow with the book for now, and simply just assign methods in the, into this here. So, maybe it's a good idea to explain what just happened, what we've been doing here. So, this panel here, this is an event panel. So, this starts to get into what's called an event system. So, we subscribe methods to events. So, we assign methods to these events so that when this event happens, any method subscribed to that event will be invoked. When that method is invoked, whatever value was changed, in our case this is the slider value, if we change the slider value, any methods subscribed to that event will get whatever value was changed, any updated value from the slider. So, we get a method to subscribe to this onValueChanged event. When we change the slider value, any new value will be passed on to whatever methods are subscribed to the onValueChanged event. Similarly, see this close button here? There is an onClick event. So, if I click on the button, it's going to start the onClick event. Any methods subscribed to the onClick event, they're going to be listening for when that click happens. Any methods subscribed to that event are going to be invoked. There aren't any arguments being passed in here, so when we click this button, any methods subscribed to that event are just going to be invoked. In this case, when we click close, it's going to call the settings popup.close method that was part of this script here. So this instance of the settings popup script is going to close the entire window. Likewise, we have this button here. We also have a onClick event. The UIController.onOpenSettings method is subscribed to this event. It's going to be called when we click on the button. So whenever we call the button, any methods subscribed to this event are gonna, be called. With this name here, this input field here, if we edit the text in this field, any methods subscribed to this on and edit event here, once we're done editing the text in this field, it's going to be given the name of the player that was typed into that field. That's going to be passed on to the onSubmitName method. Okay? So now we're dealing with an event system. When something happens in our game, methods that are subscribed to certain events will be called, and in some cases, they'll be passed information that had to do with that event. In the case of the speed slider here, if we change the value of the speed slider by moving that slider knob left and right, once that change happens, the slider will invoke this event here on onValueChanged. Any methods subscribed to that event will have that event. Okay, so back up. Any methods subscribed to the onValueChange event will have those methods be invoked, but they'll also be passed in the new value of the slider. Okay? Okay. Yeah, so this is an event. This is also an event. These four are all events. We only need to deal with one of them here, though. We subscribe certain methods to these events so that they listen for any changes. Speaking of events, we're now entering section 7.4, so maybe let's talk about this. So, all the events that are happening right now are just UI elements listening for when things happen with other UI elements. The game objects that we have written for our game so far, they're only talking to one another. So, here's the thing. The UI is working independently of all the game objects in the scene. If we take out all of our game objects and leave the UI will still work. If we take out the UI and leave all the game objects, all the other game objects, the game will still work. We just won't have a UI. In fact, we started this project without a UI, and now we added one. Let's get them to talk to one another, okay? Okay. So, one way to get these two disparate sets of objects to talk to one another is by having references to one another. So, the scene controller could have a reference to the UI controller and vice versa. So, any events that happen with the game, we call relevant methods in the UI controller to update values in the UI. And if we change anything about the UI, say a speed setting, we're going to pass that information on by invoking methods related to the scene controller. So that way we can, for example, change the speed of our enemies. In fact, if you want to be specific with the case of changing the speed of the enemies, the UI controller should have a reference to every instance of the enemy in the game. That's a bit cumbersome, don't you think? So, not only is this cumbersome, it has disadvantages. So, if we have game objects with a reference to the UI controller, and the UI controller with references to game objects, this makes our game objects dependent on one another. We call this tightly coupled code. And for our purposes, this is bad. We want a means of communicating information between the game objects and the UI, such that even if one breaks, the other can still operate on its own. We want an event system. So, a messenger is a module that... So the messenger is a module that routes messages between broadcasters and listeners. Objects register to listen for specific events, assigning a function as the callback. Other objects can tell messenger to broadcast specific events. So, as I said, I like to talk about it as methods subscribing to certain events. So if a specific event happens, only methods that are subscribed to that event will get information regarding that event. If I subscribe to some YouTuber, I'll get notifications on when that YouTuber uploads a video. But only if I'm subscribed to that YouTuber. Some other YouTuber might upload on their own schedule, but I'll only get notifications on that if I'm subscribed to that YouTuber. So I like to think of it as a subscription system. So we're going to implement an event system. So in this broadcast system, some code broadcasts a message, and the code doesn't need to know anything about the listeners. I like to think about it like this. If a tree falls in the forest, does it make a sound? If there's an event system that broadcasts to listeners that a tree has fallen in a forest, and this should therefore make a sound, think about it. An event system that broadcasts to listeners that a tree has fallen in a forest and therefore should make a sound. If a tree falls in the forest, does it make a sound? In a video game context, if a tree falls in the forest, it's going to start some event called Tree Has Fallen in a Forest. And anyone who is subscribed to that event of Tree Falls in a Forest is gonna hear the sound of the tree falling in the forest, of course. So the problem with this event system is it isn't built into Unity. But let's just do something here. We're going to go back to the author's GitHub repo, and we're just gonna copy this code here. This is the code for an event system called messenger.cs. I'm just gonna copy this whole code, and or we could just download the .cs file and import that entire script. What I'm just gonna do is I'll copy that code and open up my scripts folder, create a brand new script called messenger.cs. There we go. I'm gonna open this up, Control A to select everything, delete everything, paste. Some Unicode characters, just whatever. So you'll notice that this is one of those rare cases where we write a script that does not inherit from mono behavior. And that's because we are not attaching this script to anything. It's its own separate system it's its own system that is, I guess, independent of game objects. So we are not going to attach this messenger.cs script to anything. And because of that, we don't need it to inherit from mono behavior at all. Yeah, there are going to be scripts that so far all the scripts we've written inherit from mono behavior with the idea that they're going to be attached to some game object. This is one of those cases where this is not the case. There's going to be at least one other case where we write what's called an interface. An interface is going to be inherited by some other script. So, interfaces don't get attached to anything. They're inherited by other scripts that may or may not be attached to game objects. So, we're not attaching this messenger script to anything. We're just gonna use it as part of another script. Okay? So, we're gonna make yet another script. And that is a script called game event. Actually, what I'm going to do is I'm going to create a separate folder called event system. I'm just going to drag and drop that messenger script into that folder. And once again, this is for organizational purposes. We are writing so many scripts that it's probably a good idea to organize everything. So, event system scripts, I am going to add a new C# script called game event. So, game event is yet another script that does not inherit from mono behavior. So, we're going to remove that. It's also what's called a static class. So this class is just going to be a container for our different event types. So we're simply going to say public const string enemy hit equals enemy hit, and public const string speed changed equals speed changed. So what this class is, it's just a container for the names of different events we're going to have in our game. So there are two events, and they are enemy hit and speed changed. So it's a static class because we are not making instances of this class. There's going to just be the one instance that exists in the whole game. And again, it's not going to be It's not going to be created or whatever. It's just a container that contains names of different events that our game is going to have. Right now, as it stands, this text object here, when I play the game, all it does so far is count up the number of seconds that have elapsed since the start of the game. What we want to do is change it so that when we kill an enemy, it will increment the count up there by 1. That requires a event. So we're going to create an event where the UI controller subscribes to that event so that if an enemy is hit, we increment that hit value by 1. So let's work on that first. We're going to add a private int for the score, and that is the number of enemies hit, the number of enemies successfully hit by the player. So let's go back to our UI controller. We'll add several fields we'll add a field and several new methods here. So private int score. I like the convention of adding an underscore to any and all private fields. That's just how I code. Do what you want do what you want in terms of coding style, as long as it's consistent and makes sense. But I would recommend that you find a code style guide. Doesn't matter which one, just pick one and stick with it. So I personally like the convention of curly brackets on the same line as the declaration for a method. That's just me. At the same time, I like the convention of having an underscore to denote private fields. There are other ways to do that, but I just use an underscore because it's easy. Okay. This might just screw me up when it comes to writing code straight from the slides, but let's put up with it anyway. We're gonna add a method called onEnable. Not that one. Try it again. OnEnable. Private void onEnable. We're gonna say messenger.add listener game event.enemy hit and then we're gonna pass in as a method onEnemy hit. Oh, I actually don't need the parentheses here, so there we go. Now it's throwing an error because I haven't written the onEnemy hit method yet. So maybe let's do that next. OnEnemy hit. We're gonna say score plus equals 1, and then score label.text. Oh, hold on. Score plus equals 1, and then score label.text equals score.toString. There we go. So now, every time we hit an enemy, if we hit an enemy, this method, which is going to be subscribed to the enemy hit event, will increment the score. So, messenger.addListener. I like to think of this method as the moment you subscribe to an event. So conversely, we need a means of unsubscribing from an event. So we need an onDisable method. So onDisable messenger.removeListener. We're going to say GameEvent.enemyHit, and we're going to pass in the same method as before, onEnemyHit. So as I said, I like to think of an event system as subscribing to when specific events happen. But when we're done, we need a means of unsubscribing from these events. So, on enemy hit is subscribed to the enemy hit event. When we hit an enemy, we're going to increment the score by 1. And this is agnostic to the existence of enemies. If there were no enemies in existence, then all this would still work. But it's just that we won't be able to increment the score because there's not anything to hit, of course. Note that we have on enable and on disable. This allows the script to respond to being activated and deactivated. We add a listener to the enemy hit event on enable, and conversely, remove that listener on disable. The listener is part of the event system, so when an event happens, it calls on enemy hit. When we hit an enemy, when the enemy hit event happens, any methods subscribed to enemy hit are called. And in our case, it's going to increment our score by 1. Okay, so let's go back to our ray shooter script. So, it might be a bit of a pain to find, but I remember a million years ago when we wrote all this code for enemy being hit. So, if the player... Okay, so let's recap what's going on here. If the player presses down... If the player presses down on the left mouse button and it is not over a UI object, we're going to create a ray from the center of the screen and have it extend out into the scene. Whatever we hit with that ray, we're going to not only figure out where in the scene that object was hit, but we're going to determine whether we hit an enemy based on whether hitObject.getComponentReactiveTarget is null or not. If it is not null, that means the object that was hit had a reactive target component attached to it. It's an enemy. Therefore, we say target.reactToHit, so that way the target dies. We play its death animation coroutine. At the same time, when this happens, we need to say messenger.broadcast. It's going to broadcast to the world, but only to those who are subscribed to this event, game event.enemyHit. Okay, so now the event system, we're going to broadcast this event of an enemy being hit to everyone who is subscribed to the enemy hit event. Since the UI controller has the onEnemyHit method subscribed to that event, that method is going to be called and it's going to increment the score by 1. Let's try it out. Okay, nothing's happening, and that's because it's still set up so that the count is going up for the number of seconds since the game began. So we need to change that code now. So, let's simply comment out that line. So now, we have our score incrementing every time we hit an enemy. Let's just fix up our start method here. So we're going to say setUpPopup.close, but we're also going to add 2 more lines. We're going to set our score to be 0, because of course, this is the start of our game. Score equals 0, and scoreLabel.text equals score.toString. So when the game starts, we're going to have a score of 0, and it's going to reflect in the UI. So the UI keeps track of our score. The UI keeps track of the score. The UI keeps track of how many enemies we've hit. So far we've hit 0, and if I try to hit this enemy here, it goes up by 1. So if I drive my car all the way to this room full of red cars, hit, 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 hit. Now it's a massacre of red cars here, so a little bit disorienting given the... Yeah, it's a little bit disorienting because the cursor can now leave the screen, but we got the basic gist of what is going on now here. So we can hit enemies so that we hit them and the score goes up by 1. There's a little bit of a problem. This might be something worth debugging as well. So once something is hit, it will only give us a point if the enemy went from the alive state to the dead state. So if we hit it again and it's already dead, we should not get another point. That could be worth debugging, so I'm gonna try to do that right now. Okay. Let's see. So in the race shooter, we are getting a reference to the reactive target script. If I hold down Control and click this in Visual Studio, I can open up the reactive target script. Let's see if we can access a field for... Okay, so I'm thinking about it in one of two ways. So private coroutine that anim, and we can say that anim equals start coroutine. So now we have a reference to our coroutine. If okay, so maybe not that, but rather public coroutine that anim, and in curly brackets, private set semicolon get. So with this, we can get a reference to our current that animation coroutine. If that coroutine is already running, then this is going to be not null. So if our race shooter, what we can do is this. If okay, so this is our race shooter. If target dot that anim is not equal to null, this should bug fix the fact that we can repeatedly hit the enemy for more points. So let's try that. This is just me experimenting. So this is not part of your... This is not going to be part of any upcoming assignment, but I do welcome you to bug fix it. Okay, I think I broke it even further. Okay, it's not quite working the way I want it to, so maybe I'll have to not worry about that for now. Okay, so that didn't work, so I'm gonna have to think about this a little bit further, but the idea is I tried to bug fix the fact that okay, I I think I see it now. I think I see it now. Yeah, I think I see it now. Okay, let's see if this works. Let's see if this works. Again, this is not part of any upcoming assignment, but I do encourage you to bug fix any issues that you might find problematic with this game. So, if I hit an enemy, there's still gonna be the issue of that, but now, at least, when we hit an enemy, once it's hit, it doesn't die when it's already dead. Still gotta fix the issue of the score going up, though. But I think that's a simple issue to be fixed in here, so... Okay, I think I inverted the logic here. So, if that was already null... Okay, so we actually need to swap the order of this code a little bit here, so... Yeah, I'm just debugging on the fly right now. So... We're gonna... If that was already null, we're gonna say react to hit. It still doesn't quite work though. Oh, that's okay. That's probably because that was a different enemy with a different script. But yeah, now we have it so that any enemies we hit will only give us 1 point and 1 point only. If I try to hit the same object again and again, I won't get rewarded any more points. So yeah, you just saw me debug one big issue with this project here. Nice! That was really neat. That was fun to bug fix, by the way. But we kind of got sidetracked here. So, now, the basics is the basics is the same either way. If we shoot down an enemy, we're going to broadcast to the world that we hit an enemy. Anyone subscribed to that event is going to get information that we just hit an enemy. In the case of our UI, it's going to increment the score by 1. Okay? Okay. Okay, so now let's change the code for our wandering AI script. So the wandering AI script that was the one that the enemy has. So the wandering AI script, let's open that up real quick. That script was this one. So if you recall, this was a script that reacted to the player's presence. If it does a raycast, or rather a sphere cast, to detect whether there's an obstacle in front of it. If it finds an obstacle, it's going to turn around. But if it detects the player in front of it, it's going to shoot a fireball at the player. So, we're going to add a few methods to this. Methods to the madness. Let's add them before our start method here. So, public const float base speed equals street f. So this is our base speed. We're going to add a method that subscribes the enemy, or rather the wandering AI, to the event speed changed. So, on enable. So this is an event that passes a float to whatever methods are subscribed to the event. So it's messenger, but with, in angle brackets, float. So messenger float dot add listener. We're gonna say game event.speed changed, comma, on speed changed. Now it's throwing an error because we haven't written the on speed change method yet. Let's do that right now. No, not that one. On speed changed float value. And private void on speed change float value. And then we're going to say speed equals base speed times value. So this is going to change the speed of the enemy. Finally, we're going to add a method to unsubscribe from the event system if we are to disable the wandering AI. So, I'm going to say private void on disable messenger float remove listener So the unsubscribing here is important because if we subscribe to this speed changed event and forgot to unsubscribe, once this game object is disabled and is removed from the scene, if we forget to unsubscribe, we're gonna try to call an event for a game object that no longer exists. So that's why we must unsubscribe. Once again, I like to talk about an event system as things that you subscribe to. So now we have all this code set up. If we change the value of the speed slider in our UI, it's going to change the speed of all any game objects in the game. But we're also going to do the same thing for the player. So I'll just cheat a little bit and copy all this code and add it to the FPS input script. So the FPS input script, we wrote that a long time ago. And I'm simply going to add them here. There we go. Probably a good idea to move the start method so it's out of the way of these methods. There we go. So now, if we change the value of the speed slider in the UI, it's going to broadcast an event to everyone who subscribed to the speed changed event. And then from there, they're going to get a new speed value. Now, we're going to add code to the settings pop-up script. That code goes in the onSpeedValue method. We're going to say messenger float .broadcast game event.speed changed. That game event.speed changed, that's just the name of the event. And then we're going to pass in the one argument that is the new speed value. There we go. So when we broadcast this event, it's going to come with an argument that's going to be passed in to all methods subscribed to this event. So the wandering AI has on speed changed subscribed to that speed change event. And so does FPS input. So on speed changed is going to be called when the speed changed event happens. Since they're subscribed to that event, they're gonna get the new value they're gonna get the new speed value. And then they're gonna change their speed accordingly. So that's actually the end of our slides, but let's see how well our game works now. So this is a long video again, so it's nearly 2 hours long once again, but let's try it out. We have a means of changing the player name, but that's not going to be used. But you can imagine coding your system so it displays a game over screen, and it also displays the name of your player. But let's try this out. I can move out of the way, and the reason why that this enemy here does not work is that's because I think that one's a different enemy, or I programmed that one wrong. But if I move around the scene, I can hit this enemy here, hit it again, but I can change the speed of. Okay, I need to change a bug with my speed slider here. I think the bounding box of the text is too big that it's overlapping with the speed slider. So let me go fix that real quick. I think I know what to do with that one. So the pop-up. Let me just minimize all of these. So so we have these 4 things in the pop-up. I want the slider to be in front of everything else. I think that's what's going on. The slider should be in front of the text, and I think the text, I made it way too big. So really what we should do is change the size of this speed rectangle here. So instead of being that big, we can change the size of it and then reposition it. But alternatively, we should probably have the slider be in front of the speed text, because say the bounding box for the speed text is way too big, and I think that was blocking me from trying to adjust the slider. So let's try it once more. If I open up the thing here, I can now change the speed, so no. So now everything should be moving faster. Doesn't look like everything's moving faster yet, but maybe I can try it again. Okay, so it's not quite working, but okay, so I did some looking around, and let's look at that smart. Okay, so it turns out I have the smart enemy script instead of the yeah. So I'm using the decoupled script. So what I just talked about with setting up our so everything, all the changes I made would only apply to the original enemy. So since I have the original enemy out in the scene already, it's this guy over here. If I change the speed value, it should result. Yeah, there. So this is the original enemy, but the cars that I have in the scene, those are using the smart movement script that I made in that bonus video. And yeah, the problem is because I'm using a different script. I didn't write them up to subscribe to the speed value changed event. So if I wanted to fix them up, it's a simple case of going back into the script for the smart movement script here and adding those methods that would change the yeah, so if I want the smart movement script to work with the changes that I make to the speed value here, all I need to do is copy these lines of code and paste them into the smart movement script. So the smart movement script, I talked about that in a bonus video where I decoupled. Oh, I forgot the speed value. Okay, so that really should just be movement speed. So there we go. That hopefully should fix up the smart movement script. So now they are listening to whenever I change the script. No, change the slider value. So again, this is getting quite long. So let's see. So we have these cars moving around, and I'm going to change the speed really high. So hopefully they move faster. I'm going to... Yeah, look! Now, they're moving much slower because I moved this speed slider all the way down, close to 0. And now, they're moving, but slower. So if I change the speed slider to be at the max speed, now they're moving much faster. Look at that! It's working! It's working! Yeah! So if we have... Okay, so since the slider, speed slider determines how fast game objects are moving. If we want other scripts that have movement to subscribe to that change in speed value, all we gotta do is copy paste these lines of code, but in the case of my smart movement script, it doesn't have a field called speed. It has a field called movement speed. So that's the one change I had to make here. So movement speed equals base speed times value. So if I change the slider value, this onSpeed change method will be called and get a value of the new speed value. And then my movement speed will now become that new speed. We did it. Alright, so now we've looked into making an event system for Unity such that if we have certain events in our game happening, methods that are subscribed to that event will be notified. No, scripts that subscribe to that event will be notified of what's going on. So it's through an event system that we can decouple our scripts so that they operate regardless of whether everything else exists or not. So yeah, that script that we wrote for the event system, the messenger system, all this does is create a event system where if a certain event happens, we can broadcast that event, and any script that is listening to that event will any script that is subscribed to that event will get a notification of what's happened, and in some cases they'll get a changed value. So this event system will work for up to 3 arguments in a function. So if we have a method that requires 2 arguments to be passed in, well, really 3. If we have if you have a method that has 3 arguments, we can pass in up to 3 arguments and have an event that works with 3 arguments. So yeah, that is our event system. And the fact that I have a smart movement script, and in addition to the original reactive target script, or rather wandering AI script, it's just only a few lines of code that had to be changed, or rather added, to make the smart movement script also listen to changes to the speed slider. Okay? Alright, so now our game is done for Chapter 7. That was quite a lot. We had to set up a UI that has these text elements in set up. We had to set up methods that would make the pop-up appear and disappear, and then we had to set up an event system that would broadcast messages from game objects to the UI, and from the UI to game objects, so that if one event happens, we can, for example, update the score on the screen, or change the speed of all of our moving game objects. Alright, so that's going to be it for Chapter 7. It is quite a lot, but yeah, I think I'm going to call it here, and we'll see how far we get with this chapter. So, Chapter 7 is all about putting a UI into the game, and also having, it's all about having adding a UI and creating an event system so that the game objects in our game will work regardless of whether the UI even exists. The UI should exist regardless of whether there are any other game objects in the game. The messenger is just an intermediary between the two to pass events, to broadcast things from one to the other. So that way, if one breaks, the other if one breaks, the other doesn't. So that's why it's a good idea. So that's why we look into an event system. Okay? Okay. So, Chapter 7. That was Chapter 7. Chapter 9. It's actually going to be our next chapter. That is all about adding interactive objects in the game. So, we are going to adapt our first-person shooter so we can add interactive objects. Stuff we can interact with, you know? That's gonna be an interesting thing, because Chapter 9 was adapted. Chapter 9 was meant for a separate project, and that was actually which is actually a third-person shooter. But the point is, we can adapt these instructions so that it works with, well, any project we want. So this is going to be a first-person shooter. If you want to make a different game, I encourage you to do so. It's just that we'll have to consider different things for different kinds of games. If it's a 2D game, then we need to really rethink what to do. If it's a third-person shooter, that's a little bit easier to work with, because we can, in the super trivial case, we can just simply move the camera up into the air. But now, raycasts won't quite work the same way. But let's just work with this as a base, and if you want to experiment with other things you want to add to your game, once again, I highly encourage you to do so. So, with that, I'm going to end the video, and we'll meet up in the next video. Alright, take care.